So let us start the.
Okay, sir. Okay, sir.
Good morning, all the participants. Welcome to the second day of the program on alternative biofuels on the session 4. And start with today's session. Dr. Sailesh V. Chanpatna, Professor and Head, Department of Mechanical Engineering, D.Y. Patil College of Engineering, MBA, Pune. Just before start the session, I'll be introduce small biodata and brief of the professor. Dr. Sailesh V. Chanpatna is a professor and head of the Mechanical Engineering Department at D.Y. Patil University, MBA, Pune. He has graduated from BUB College of Engineering Tech. Currently, it is called the KLE Technical University. Master in the Heat Power Engineering from the Savitribai Phule Pune University and doctorate from the V2 Belagaon. And sir, also he has worked as the head of the mechanical section at Government College of Technology, Solate of Oman for over 5 years. He has about 24 years of teaching graduate and postgraduate students and guided research project in the areas of renewable energy, refrigeration and air conditioning, heat transfer, alternate fuels for the IC engine, applications of artificial intelligence, and optimization of engineering system. Sir has lifetime member of the IST and Combustion Institute, USA. He has also published books and research papers in the national and international journals proceedings. He has also attended international conferences and presented paper, also published for patent. This is the small introduction to the today's research person, that is Dr. Sailesh V. Chanpatna. Sir, please hand over to you. Start the session. Thank you very much.
Thank you, sir. Thank you very much. And thanks. I thank Dr. Harishchandra Ashtigi, professor in PDA College of Engineering, as a convener of this ATAL FDP program, for inviting me. And good morning to all participants. I will share my slide. That is, my topic is use of biofuels in IC engines. So as the FDP is on alternative fuels, especially biofuels, so nowadays biofuels use is in large scale in all the sectors of society. Even lubricating oils are also made in biofuels. The use of biofuels is not new. It is a very old thing. And Rudolf Diesel, the diesel engine when he manufactured. So first he tested the engine with biofuel only. That is, he used the peanut oil in Paris in 1900. And the liquid fuels made from resources such as food crops. It is researched for more than over a century. So that biofuel interest was mainly among some specialists. So most of them they were using for the research projects, but it was not noticed by public. So, but with the exception of the Brazil from last 50 years only they started doing research on biofuels. And they are the second largest user of biofuel also. However, towards the end of 20th century, number of challenges to the modern way of life combined to bring biofuels to national and international attentions, mainly because of energy security. So the cost for which is growing demand for the fuels, and also the reduction in supply of oils. Then again, international conflicts and depends upon energy imports. It causes to search for some alternative resources of fuel. So due to this, the interest in biofuels further intensified with the search for new opportunities It has opened a new opportunities for economic development, especially in agriculture. So this was particularly relevant in emerging economies such as India and China. So we will look at the scenario of UK and European Union. 1980, 98 and 2009, the production of biodiesel in the European Union increased more than 10 folds. So by this, you will understand how the urge for the biofuels has been increased tremendously throughout the world. Currently, biofuels make up more than 3% of UK road transport fuel. Worldwide, it is expected that by 2030, biofuels will account for 7% of the road transport fuel because it reduces the requirement of the fossil fuels if the use of biofuel is increased. So we will discuss about use of biofuels in diesel engines. So most developing countries like our rely on fuel imports, which controls the budget of the nation. So rising fuel prices hampers our commodities also. Once the fuel price rises currently in India, the fuel price is rising, it increases all other subsidiaries, all other subsidized this food cost, transportation cost once increases, it subsequently increases the cost of all other things. So diesel engines are primary sources of mass transportation, which involves trucks, trains, ships, submarines, and in India, the cars are also manufactured in diesel engines, using diesel engines. So biodiesel marks a prominent source to power these engines and highlights a requirement of least possible engine modifications. So in Indian Railways, they have reported that they uses 3,000 million liters of diesel in 2009. So right now it has been increased to 4,500 million. So in 2009, the national policy on biodiesel, it is approved in May 2018. So it was introduced in 2009. So after almost some 10 years, that has been approved. Biofuel policy is approved. The policy, the aim of the policy is to take forward the indicative target of achieving 20% blending of biofuels with fossil-based fuels by 2030. Because the research has been proved that 20% biodiesel can be used in existing diesel engines without any engine modifications. Then MNRE has set up a target of 20% blending of ethanol in petrols and 5% blending of biodiesel and diesel to be achieved by 2030. The percentage of the same currently stands at around 2% for petrol and less than 0.1% for diesel. Railway, as I told, it is using 5% biodiesel blends. It costs somewhere between 48 to 54 rupees per liter. The 5% biodiesel, it could cut this one fuel price by 30,000 crore worth. So that the 30,000 crore worth of diesel fuel imports is reduced by using only 5% biodiesel. You imagine if it is increased to 20%, how much it will be? 4 times. 4 times reduction in the import of the fossil fuel. So top 10 countries consumes the fossil fuels throughout the world. You can see this. US is the first consumer. Then next is so here the India stands fourth, but the difference you can see here between the India and Japan. India, Japan imports 4,400, India imports 3,250. So India also is a major importer of the fossil fuels. So energy shares by various fuels throughout the world, you can see here. The nuclear fuel lies very below than compared to all other renewable. We can say it is increasing. It is from 1980 to 2030, use of renewable energy is increasing year by year. But it is very less compared to our liquid fuels. Liquid fuels consumption is highest throughout the world. So in order to reduce this consumption of liquid fossil fuels, we have to go for some alternative fuels. So energy share by various fuels, you can see here. Here also renewable energy consumption rate is increasing by year. The projected use of the renewable energy by 2030, you can see it will increase, but it is not going to increase much. So whereas the use of coal is increasing continuously, the nuclear fuel it is also increasing, but not too much. So now we will discuss about the transportation sector. Main sector of energy consumption, which mostly uses crude oil based biofuel, that is a fossil fuels. So it affects the energy security level of the country and causing the crisis economically and politically. And also there is a global threat to carbon dioxide emissions. So the emission increases, the global warming also is a big threat to any country. So world's carbon dioxide emissions you can see here. So it is continuously increasing from 1800 to 2000. You can see here there's a drastic rise in the total emission of carbon dioxide. So by 2030, they have imagined that whatever they imagined, already it has reached 3/4. So greenhouse gases warming contribution, carbon dioxide is the major contributor for the greenhouse gas emissions. 50% it is contributing for the greenhouse gas emission. Nitrous oxide, you can see it is also contributing 8%. But nitrous oxide is very harmful for a human being. Chlorofluorocarbon, even though it is banned, still it is contributing 20%. So lifetime availability of fossil fuels you see here. So from Saudi Arabia, its daily extraction is 88 lakhs barrels and resource is 2,60,000 crores barrel reserve is there. It is going to last in another 81 years if it is used in the same rate. So Venezuela, you can see here, the reserve is very less, but extraction is also less here. So it will last for 91 years. So Canada, it will, the reserve is one, but extraction is less here, even the reserve is less, extraction also less. So availability is 1,22 years. So you can see here, so resource of the fossil fuels is not uniformly distributed throughout the globe. It is disintegrated. Geographically, it is disintegrated. That's why it is causing a cost of equal duty. So if the fossil fuels are used in same rate, then it is going to last. Finally, when someday there will not be availability of any fossil fuels. So India, you can see here, fossil fuel availability is very less, 6,000 lakh barrel only. So daily extraction also it is very less, 9 lakh barrels. So another 18 years, all the fossil fuels will vanish. So now there is urgent need for the use of some alternative fuels. That is, we must have to go for renewable energy. So daily consumption in lakh barrels, you can see here. America, it is at highest 208, Europe 146, China 69, Japan 54, Russia 29, Germany 26, and India 24. So in an average within 65 years, all reserves will be empty if it is used in same rate as it is used currently. So what is the solution for this? Solution for this, we have to go for renewable alternative fuels. So renewable alternative fuels, yeah, it should be produced locally, that is domestically produced, according to availability of the resources. Then it should be derived from renewable sources, and also to reduces harmful pollutants and also reduces exhaust emissions of the engines. So we'll discuss what are the biofuels. See, biofuels are liquid fuels which are made from variety of sources of biomass. Biomass may be a plant material or any type of crops or recycled or waste vegetable oils. See, plant materials, already a lot of research has been done by using Karanja, Jatropha, Calophyllum, Inoculum, and all domestic oils, soybean oil, palm oils are also used here. And sometimes, it is extracted from waste cooking oil also. And many types of crops also used for producing biofuels and recycled or waste vegetable oils. So biofuels, it can be used in internal combustion engines as a replacement or complement of petrol and diesel. See here, a lot of research, if you see in India, most of the researchers have used stationary engines. See, there is a main difference between stationary engine and transportation engines. See, these engines are designed in 1970s for to operate using diesel as a fuel, fossil fuel, that is diesel as a fuel. So around in 2000, that is Central Pollution Control Board of India, they have brought norms, emission norms for the stationary engines which are used for diesel gensets, irrigation purpose pumps. So for this also they have brought stringent norms in 2000, and that they have given deadline to implement these norms before 2005. Otherwise, they would have stopped the manufacturing of engines for diesel gensets. So what the companies have done to make the emissions within the limits of the CPCB, Central Pollution Control Board of India, they have optimized certain things within the engine. They have optimized the cylinder combustion chamber shape. So, and also that they have optimized the nozzle hole size, nozzle hole length divided by diameter ratio, L by D ratios, and number of injection holes within the injector. So there are various types of combustion chamber shapes in direct injection diesel engines, it. So reentrant type, toroidal type. So they have optimized these shapes so that there is a proper combustion. What is the reason for harmful emission? Mainly it is because of the improper combustion. So proper combustion can be done in diesel engines by making modifications so that there will be a proper air motion. Swirl and proper swirl of the air should be there so that it leads to proper mixing of the diesel and air. So it leads to proper combustion. And also the injection parameters of the diesel also is very important. So many operating parameters are there in diesel engine which affects the combustion of fuel. So that by 2004, 2006, they have given again extended deadline. By 2006, all the companies, manufacturing companies, they comply with the CPCB norms. But here the research on the transportation engines are very less in India and throughout the globe. But that is the reason the biodiesel is not used in more than 20% in transportation vehicles. So reason for promoting biofuels, as I told you already, so to contribute to the security of the energy supply, and also to contribute to the reduction of greenhouse gas emissions, and to promote a greater use of renewable energy, and to diversify agricultural economies into new markets. So it causes a huge market. So agriculture sector will improve. So what are the two types of biofuels? So biofuel, there are two types of engine. That is, one runs on petrol, gasoline, we call it as a petrol engine. Another one runs on diesel, we call it as diesel engine. So bioethanol is already used as a substitute or additives for petrol. So in order to reduce the percentage of use of that fossil petrol. And biodiesel is a substitute for diesel in diesel engines. So there are mainly two types of biofuels which can be used. See, so many crops are there which has been already tried, and it is going from the 20% of these crops from these oils which can be used. which can be used in the existing diesel engine. So soybean is there, corn is there, sugar cane, then sugar beet, and switchgrass, cassava, agriculture waste, algae, camelina, jatropha, fungi, fat, calophyllum. See here, these soybean, corn, sugar cane, you can see, soybean, corn, you can see these are the, we call it as edible oil. These oils are used for making food also. So what happens if it poses a competition in the food market, because once if you use it for biofuel, it poses competition in the food market. So people started using non-edible oils like calophyllum, jatropha, karanja. These are non-edible oils which are not used in which are not used in food industries, although it is used for some medicinal purpose. So it may not pose the competition in the food market. They started using these non-edible oils. So edible oils, we call it as first generation biofuels. That's like when people started research. They started with and national energy this one also policy. They also imposed that there should be a least use of this edible oils for making biofuels. Then national energy policy also they imposed some norms for making biofuels. Then people started shifting, researchers started shifting into the use of non-edible oils. So non-edible oils, we call it as a second generation biofuels. Then another one resources was found to be more promising. Its yield was very high compared to all other this one, and also it is not does not pose any competition in the food market. There is algae. But only the drawback of algae is extracting the biofuel from algae is very complicated. It needs complicated machines. Still, it is under research. Still, it has not emerged as a emerged widely globally for using it. But the biodiesel, which are manufactured from algae oil, found to possess properties very similar to diesel. So we will see in future what happens about algae. Still, researchers are going on. Presently, 95th of the world biodiesel is extracted from edible oils. So these are called as first generation, as I told you, sunflower, soybean, peanut, palm, cottonseed, linseed, sesame, corn, etc. So second generation biodiesel has non-edible resources, non-edible oil, jatropha, karanja, calophyllum, etc. So there is a wide opportunity in the area of using biofuels based on non-edible oils. The current potential for non-edible oils like calophyllum, that is called as in Karnataka, only in Maharashtra, karanja, jatropha, rubber seed, grapeseed plays an important role for biodiesel production because it is available region-wise. In some state, there may be more availability of honey. In some state, there is more availability of karanja, jatropha. In Maharashtra and Karnataka, the government has given directives to develop honey crops because it grows, this honey tree grows without water also, in desert also it can be grown. It does not need any watering or without anything it will grow anywhere. So in Maharashtra, some 1,000 acres of land in Konkan region and also in Karnataka, Shivamogga, they are cultivating this honey trees because its yield also is more compared to other non-edible oils. So advantage of using this feedstocks, non-edible feedstocks for biodiesel production. So cultivating non-edible oil feedstock in waste lands, that is very important. We can use the waste lands for cultivating non-edible oil feedstocks because it does not need any special lookout or any treatment. So it will grow without even watering also in barren land it will grow. And it generates local employment opportunities and can reduce a lot of carbon dioxide emissions. That is a contribution for greenhouse gas emission will reduce. to a larger extent. And due to it is non-edible in nature, they do not pose any market competition with edible oils. The conversion of non-edible oil into biodiesel is very much similar to edible oils in terms of production and quality. The byproducts that are created by conversion may be used for heat and power generation. So it can be converted into briquettes, and it can be used in power plants also for power generation, for producing steam, or in the other chemical process also it can be used. So seed cakes are often used as fertilizers also for soil enrichments. Seeds can be dried and it can be made in cakes. And as it is in liquid nature, portability is easy, and it is having higher enthalpy, but also it is renewable in nature. The aromatic content is lower compared to fossil fuels. Another advantage of biofuel is having a lower sulfur content, and it is biodegradable. We will see the summary of research publications globally. Research publication related to use of biofuels in engines. In 2010, it was 1988, but 2018 it is 4061. So globally, the research publications, it is increasing year by year. It is increasing. And from 2016 to 18, it is remaining almost constant year. That is a research publication related to biofuels. Only that concern here is the research, whatever it is done, by it may be academic research, it is limited to their getting degrees. But what is the main concern is it should be transferred to the companies, whatever the knowledge which is coming out of using these biofuels in engines, it should be transferred to companies and should also collaborate with some engine manufacturing companies. And engine manufacturing companies also should go for testing of their engines by using the biofuels, so that it can increases the use of biofuels commercially. So main thing, the drawback for not using it in commercial use is the research is not transferred and to the companies. Companies also should take interest in the use of this making research using biofuels of the engines. So for this national policy, they have to take it in seriously, and they have to look out for this biofuel use. You can say that nowadays electric vehicle is coming into market. See, electric vehicle is found to be very expensive, and it has also got its own drawbacks. But already a lot of research has been done in diesel engines. The same engine, it can be used for biofuels. If it is used for biofuel use, it will not make any additional cost. So that research, if it continues, so what I found initially, the use of 2% biodiesel without any modification, and then it has increased to 5%, and now any researchers can say blindly that 20% biodiesel can be used in a existing diesel engine without any modification. And I have found some researchers, they found that even by some modifications, they can go for 50% or 55% also, and 60% also I have found. So these researchers, it will be benefited when it is implemented by the companies which are manufacturing it. And they should make some modification in the policy also, so that it can be used widely, and also that regionally available feedstock can be used. So now we can see here publication trends per year and use on use of biofuels in vehicular engines, that is transportation engines. This is very important here. So in 1994, there was almost zero publication. It started here, it's almost zero here. Then it started increasing slowly up to 2004. Then from 2004 to 18, you can see there is a rapid rise in the publications on the engines. 2018, you can see it was almost more than 400 research publications per year. Then publication country-wise, if you see here, India is having the highest publications. You can see it is more than 1,300. Then if you see Indonesia is very least, but it is publishing papers, technical papers, and Japan also least. And it is increasing here onwards. So next to India, United States is having the highest publications. Then Malaysia, you can see Malaysia is the largest manufacturer of palm oil, and they export palm oil biodiesel also to many countries. Then next you can see Turkey. Then China is also showing interest in the use of biofuels in engines. Then Australia, Iran, United Kingdom, Brazil, Italy, South Korea, Spain, Egypt, and many countries have published only one paper or two papers. For example, Venezuela, Qatar, those countries also found many small countries. They are publishing only one or two papers per year. It is not taken easily. Then publication trend and use of biofuel additives. See what happened that biodiesel, when they were using the diesel engine, they found 20% it can be used without any engine modifications. Many researchers, only few researchers have said it can be used up to 60% with some modification in the engine. And the drawback of biofuel use, what they got, the performance was slightly compromised, but emission was reduced drastically. But only the drawback was that NOx percentage was increased with biofuel, because biofuel contains more oxygen content. There was a better combustion. NOx formation is mainly because of air temperature during combustion. So in order to reduce the NOx and also to improve the performance, researchers have used many additives. Some researchers have used nanoparticles, and also different nanoparticles have been tried. And some have combined two or more biofuels, and some have added some more chemicals into that so that it reduces the NOx. And EGR, EGR is used in petrol engines. So like that, using additives also has been increased here. By 2019, it is more than 65 around 65 publication has been found globally by using the additives also. So what this trend it indicates, the use of biofuel has been reached maximum value. Then people started using the additives mainly to increase the percentage. So if the without additive, if you use 50% without any engine modification, if you add some additives, it can go up to 25-30% also have been. So, but many researchers are interested in blending of biodiesel with fossil diesel, petroleum diesel. 100% biodiesel has been tried. The emission has reduced drastically, but performance had to compromise on the performance parameters. See global biodiesel adoption. You can see here. We take the Brazil as an example. So Brazil is using a biodiesel made from soybean oil, that is 64.84%. Maximum biodiesels are produced from soybean oil. Then 15.5% is produced from bovine fat. And other fat materials are used to produce biodiesel, that is 10.73%. Then 3.73% is produced from pork fat. Then palm oil contributes to 2.55%. And so many other feedstocks they usually it amounts to 2.64%. But majority of the biodiesel use, it is from the source, that is a soybean oil. Again, soybean oil is a edible oil. It poses competition in the food market. You can see here the countries. So biodiesel producing countries in 2017, you can see here. So US is again, it is producing around 6 billion liters of biodiesel per year. Then Brazil is second largest producer of biodiesel is Brazil is producing around 4 billion liters. Then the next comes Germany. So next is Argentina, then China, then France, Thailand, Indonesia, Canada, Netherlands is producing, Netherlands also producing some biodiesels, Spain, Poland, India. You can see, even though a lot of research is going on in India, biodiesel production is very less because here the engine manufacturers are also the public is not aware of the advantages of biodiesel use in the diesel engines. So even though a lot of research is there, that use production of biodiesel is very less in India. Colombia, you can see the biodiesel production is more than in India. So the India, a lot of research is going on, but biodiesel production is very less. So this biodiesel production can be increased in India also, only by making aware the peoples, the manufacturers, then also oil producing companies. So many are producing oil, they are producing with this one edible oil. So they can produce it with existing plant, they can produce the non-edible seeds and they can produce the edible oil, non-edible oils also, and later on that can be converted into biodiesel. Because producing biodiesel on mass scale, it reduces the manufacturing cost. If you produce it on small scale, the manufacturing cost is huge. So top major countries with expected high biodiesel productions, you can see here. So United States growth index is around almost 6%. By 2030, they can produce 8 billion liters. Then projected use in billion liters, 6.9 liters it can be. So blending ratios also you can be by 2030, the expected blending ratio is 15% in United States to the diesel, because a lot of diesel is used in transportation vehicles in United States, that is trucks, versus they are using biodiesels. Canada, you can see with blending ratio 10 by 2030, they can use almost 5 billion liters. European Union, they are ready to use 20% by 2030, because this is forecasted with the current year data. Then India, you can see it is showing 10 to 20%. So projected use, it may be around 31 billion liters. So if the researches goes on in the same trend, this percentage may increase also. So it is forecasted with the present research work and the present feasibility of using this biodiesel in blending with diesel as a fuel. In Brazil, they are already second largest manufacturer. They are expected to use 25% blending with diesel. So it will give rise to 5.6 million liters of use of biofuel. Argentina, 30%, because Argentina is also, it is a small country, they are also manufacturing biofuels in large scale. China, they are not very much interested in biodiesel, so that they may use 10% blended biodiesels. So Asian countries, we can expect to use 20% biofuel based upon the research which is going on. See, I will particularly speak about the honey tree. Honey tree, it produces seeds, and we can extract oil from it, and it is a non-edible in nature. So advantage of using these trees, it grows along coastal areas and adjacent lowland forest with broad-leaved. It is a broad-leaved, large and medium-sized leaves, and its rainfall requirement is very less. It is almost 750 to 5,000 mm per year. It grows in any region. Maybe it may be having a low rainfall or high rainfall, everywhere it can grow. And it is having multiple origins, including it is in East Africa, India, Southeast Asia, and also in Australia. The tree grows usually 3.3 feet per year under direct exposure to sunlight and reaches up to a height of 25 to 65 feet. So it grows up to 25 to 65 feet and it produces seeds, that is fruits grows as a bunch, which are in spherical in shape, and it grows twice in a year. So its yield is twice in a year, and the yield is 100 to 200 fruits per kg. And in each fruit, one large brown seed that is 2 to 4 centimeter in diameter is found. The single large seed is surrounded by a shell. We call that as an endocarp, and a thickness of this is 3 to 5 layer. So oil yield per unit land area is being reported at 2000 kg per hectare. The seed oil has a very high oil content of about 65 to 75%. The botanical name of the honey tree is Calophyllum inophyllum, which belongs to the Raceae family, commonly known as Magnostine family. As the plant has a multiple origins, Calophyllum inophyllum is known by various names around the world. See, it is existing throughout the globe in many countries. In India, we call it by different name: Poon, Polange, Ubi, Panne, Champa. In Indonesia, it is called as Bintanggur, Namplang. In Cambodia, also existing in some name: Malaysia, Philippines, Thailand, Guam, and Bangladesh, Myanmar, Hawaii. And in English, they call it as a Alexandrian laurel, Borneo, mahogany, Tamano, because it is a beautiful flowers it produces. That's why it is called as Alexandrian laurel also. You can see that when a flowers, seeds in a tree, you can see here. You can see the seed, it is spherical in shape. So the fresh fruits you can see here, and the dried seeds you can see, and seed shell, kernel, then seeds. Competition for the food, we cannot use it for biofuel production. Coconut, you can see productivity is very less compared to hectare. Soybean is also very less. Rapeseed, sunflower, peanut, cottonseed, jatropha. So Calophyllum inophyllum is having the highest productivity rate in liters per hectare compared to all other oils except palm oil. So as I told, these diesel engines are designed in the 1970s to operate it on mainly the diesel as a fuel. If you want to use biodiesel in more percentage into the diesel engine, you should understand mainly the engine operating parameters. So, and what are the effects of these engine operating parameters on the performance as well as emissions? See, there are three main engine operating parameters in the diesel engines. And as I told you in 2000, around 2000, the diesel engines are all optimized by in terms of their combustion chamber, in terms of their injectors, it is injection parameters. It has been optimized already. But if you want to use biodiesel into that diesel engines, which are mainly primarily designed for operating it on biodiesel, you should understand the effect of this engine operating parameters on the performance and emission. Injection pressure is one of the most important parameters in diesel engines. See, it improves atomization of fuel. If the fuel is properly atomized, the combustion will be better. Because the main difference between petrol and diesel in diesel engine, diesel is injected to the cylinder. Then after injection, it is going to atomize within the cylinder using the airflow, air which is already present in the cylinder. But that does not happen in petrol. Outside only it is going to be atomized. So there will be a proper mixing which is done outside the cylinder. So the air motion plays an important role here within the engine, within the diesel engine. So as the fuel is injected through the injector, the increase of the injection pressure, you can see it improves the atomization of the fuel. And also there will be a proper air fuel intermixing. And it reduces the delay period. If the delay period increases, what happens? There will be violent rise in the pressure that is not utilized in giving the output power, that is brake power. And it raises NOx also due to high premix heat release rate, and it reduces hydrocarbon. Due to better combustion, what happens? Hydrocarbons are reduced and the NOx emission increases. As that main reason for NOx emission is what temperature. So NOx emission reduces here. And the engine power improves, it leads to lower brake specific fuel consumption. That is a fuel economy. It improves. Engine power improves means it leads to better lower brake specific fuel consumption. So brake specific fuel consumption reduces, fuel economy will improve. So if the injection pressure is lower, what happens? There will be a poor fuel economy because there will not be a improved atomization of fuel. So poor fuel economy, and because of deteriorated air fuel mixing and atomization, and ignition delay will increase if you lower the injection pressure. So high injection pressure, it leads to fine atomization. If you increasing the injection pressure is advantageous, but if you increase it to high value, the atomization will be very fine. The droplets of the diesel will be very small, very fine. So it adversely affects air fuel mixture and also ultimately combustion. So engine operating variables you can see here. So injection timing also is one of the important factors. It has significant effect on brake specific fuel consumption, brake thermal efficiency, NOx emissions, going to varying peak pressure and temperature within the cylinder. So earlier fuel injection causes higher delay period due to low initial air temperature and pressure. Because during that time the piston has not reached near TDC. So far off from before reaching TDC, if you inject the fuel, the temperature of the air is less, pressure also is less. So it causes higher delay period. The ignition will be delayed. So that's why we call it as a higher delay period. So that we call it as early fuel injection. So retarded fuel injection means the piston is not far away from TDC, it is nearer to TDC. That time the temperature and pressure of the air is higher. That time if you inject the fuel, delay period will reduce. That means the fuel will take part in combustion quickly compared to earlier fuel injection. So there are two types, we call it as early fuel injection and retarded fuel injection. See here, as I told you, this diesel engine is a very complicated system, because the performance parameters we call it as a brake specific fuel consumption, brake thermal efficiency, and NOx. And also other emission parameters, emission emittents, we call it as CO2, CO, hydrocarbon, smoke also it emits. See here what happens if you want to improve the performance parameters. The emission parameters, emission may increase. Emission of NOx will increase. Sometimes the hydrocarbon reduces, the performance also goes down. So there are various parameters associated with the diesel engine. So we cannot make setup. We cannot make a proper setup for this engine operating parameters. That is injection. It may be injection pressure, injection time, or it may be nowadays variable compression ratio engines are available. We can change the compression ratio of the engine also, because that also affects mainly the engine power and fuel atomization, and also NOx also is affected by the compression ratio, and so many other parameters. There may be nozzle hole diameter to length ratio, the number of nozzles. So all these parameters which affect the diesel engine. So if you when you are doing a research, what is our main aim? Main aim is to increase the performance and improve the emission. Improve the emission means emissions will reduce. So CO2 should reduce, NOx should reduce. CO is not much problem because CO combines with oxygen and becomes CO2. So CO reduction is very important. Hydrocarbon should reduce. More hydrocarbon means what? There is not proper combustion. There is improper combustion. So fuel is not taking part in combustion, it is going out in the along with the exhaust, and it causes increase in hydrocarbon emissions. So the performance parameters, that is brakes thermal efficiency, brakes fuel consumption, and emission parameters. So these performance parameters, performance should be improved. That means what? It should consume less fuel and it gives better power. And emissions should reduce, means the hydrocarbon should reduce, carbon monoxide should reduce, nitrous oxide should reduce. So how it can reduce? It all depends upon the engine operating parameters. As I told you, the engine operating parameters of injection pressure, injection timing, compression ratio, and when you are using biodiesel, the percentage of blend of biodiesel to be used with diesel, that also may be a variable. You may use biodiesel in 20%, 30%, 40%, 50%, 60%, or 70, 80% also, up to 100% you can use it. But how to find out this optimum value of the biodiesel, which improves the performance and lowers the emissions? As this depends upon so many other parameters also, so it becomes a multi-objective optimization problem. So if there are one parameters, if you want to reduce, or two parameters, you can call it as a simple optimization problem. So a diesel engine, mainly it becomes a problem of multi-objective optimization. So in that's why IC engines are more complex due to conflicting requirements of high performance and lower emissions. So the investigator of the engine, they usually faces a complex problems of finding optimum engine operating parameters. And because IC engine is controlled by many operating parameters, as I told you, it does not have any existing physical model. So you have to find out only by experiments. So it becomes an example of multi-objective optimization problem. So achieving better result on one set of objective, that is one set of objective may be improving your performance or reducing the carbon monoxide. It leads to worsen other desired objectives. If the carbon monoxide reduces, NOx may increase, because carbon monoxide reduces means what? There is a proper combustion of fuel. There is no much unburned fuel which is coming out along with exhaust. So that's why your hydrocarbon is reduced. But due to better combustion, what happens? The NOx will increase. Carbon monoxide also may increase because it is consuming all the oxygens. Because of shortage, carbon monoxide increase means the availability of less oxygen within the engine, within the cylinder. So in order to meet multi-objective optimization of such system, one of the famous technique for this type of application is what? Genetic algorithm approach. See, many as researchers have proved that genetic algorithm tool, it can be used in IC engines effectively in order to make it up, in order to get optimum setting of this engine operating parameters. And also another one tool which is used widely in IC engines is artificial neural network. See this, what I found from this research. So many people they have used artificial neural network for making the prediction. See, there are so many types of biodiesels which are used globally, but all the biodiesels are having similar properties except there is small variations. These small variations may be in their viscosity, maybe in their flash point, or maybe in their density. Small changes are there. But all the time, for all the biofuels, every time if you go for experimentation, it increases the time and also it increases the cost. So for that purpose, what the researchers are trying to do is for making the use of artificial neural network for the prediction purpose, prediction of the performance as well as emission parameters. So in this case, experimentation time and cost can be reduced just by changing the properties of the different biodiesels and also different blends. So from that model, you can get the values of the engine performance parameters as well as engine exhaust emission characteristics. You may get it from it artificial neural network. So one of the example I have taken here for the one researchers has done by optimizing, he is trying to optimize the engine operating parameters. That is, as I told you, injection pressure, injection timing, compression ratio, and the blend also. And he's observing what are the output. Output means performance as well as emissions. So ANN could be a suitable realistic model. It means it is having a potential of capturing unknown complex relations of operational parameters of the system. So if you want to use ANN, you should have a huge data initially, because you have to train that network based upon the existing experimental data. Once these experiments are conducted vastly, those data can be fed into this ANN and train it. Then output result you will get it. Output we can validate with again experimentation or available experimental results. So if the error is very less, you can say that this ANN model works good for your data. And if you want to use it for any other biodiesel, no need to go for experimentation then. Only small changes, whatever is there, that you can adapt here, and you can use the existing model. So it reduces your time and cost. So ANN techniques are often used to forecast the required system behavior parameters once sufficient information is existing about your system. See, the experimental setup was used here. You can see here the diesel engines is there here. It is they are used direct injection diesel engine. It is a stationary engine and it is of constant speed type 1500 rpm. Then it is connected to AVL gas analyzer and also smoke meter. And there is a dynamometer you can see here. And there is a system computer here. So it is both this engine. There are various sensors which are connected to ultimately the computer. You can get the direct reading in the reading in terms of soft copy in the computer, and those readings you can use it in your analysis. It may be genetic algorithm or ANN. Then here also you can get a soft copy of the result reading from the AVL gas analyzer and the smoke meters. So those readings you can utilize well in the research. So the Kirloskar oil engine, it is of TU1 was used here. So you can see that specification of the engines here. It is a constant speed 1500 and the static injection timing. It was 23 degree before TDC. Because when the engine was stationary, we take this, we measure this injection timing. That's why we call it as a static injection timing. So gases were measured is CO, CO2, hydrocarbon, non-smoke were measured here. Then compression ratio, it can be changed in the engine, and also injection timing settings changing. See, compression ratio for changing, there is some setup here which has been made by the manufacturer of this engine. Compression ratio, it can be changed by turning this screw. There is a scale provided here. Compression ratio indicated that is a scale, and the fuel injection pump is there, by which we can change the shims are there. Okay. Changing the number of shims, we can change the fuel injection timing also. See this 1AL, whatever I have taken it here, for example here, you can see this pure diesel color. You can see as you increase the 1AL percentage, it has been becoming darker and darker yellowish. So B100, you can see that B100 sample here. So the properties of this blends also is mentioned here. You can see B100 is having 889 kg per meter cube density, and diesel is having 830. So that is a difference of almost 50 here. And as you reduce the blend percentage, B20, you can see it is very near to diesel, 840. And as you increase the blend percentage, the density increases. Ultimately, for 100, it will become 889. Then viscosity, you can see here. Viscosity of B20 and diesel. B20 is 3.6 and diesel is 2.9. Viscosity is slightly higher compared to the diesel. So B40, you can see B60, B80, it is increasing as you increase the percentage of MIL in the diesel. CT number, you can see CT number is 51 for diesel and 51.3 for B20. CT number is not affecting much as we increase the blend. So it is very near to that of diesel. Calorific value you can see here. So it's almost similar to diesel for all the blends. Ash content is slightly higher for P100. Then flash point, you can see flash point is for P20, it is almost very near to diesel, that is 65. And 100 V100 is 170. Flash point higher means what it is very much safe for transportation purpose. So it can catch fire at very higher temperature, so it is safe for transportation as well as storage. Fire point you can see it is 101 for B20 and increases here. So as the fire point also increases, it is very safe for transportation and for storage purpose. See experimental parameters. How the experimental that operating parameters of the engine were changed in experiments. So injection timing as 23 was a standard injection timing. So the injection timing has been increased by 4 degrees. That is one step ahead and one step. It has been reduced below to 23. That is in the step of 4. So 27 and 19. 27 means what? It is advanced. Injection timing is advanced. 19 before TDC. The injection timing was retarded. 19 minutes. So effect of these timings is to be studied because it affects the combustion. The injection pressure, you can see the 3 levels of injection pressure has been considered 180 bar, 210 bar and 240 bar. So for all these injection timings, like for example 19 degree before TDC, it was tested at 3 injection pressures. The compression ratio was also tested by for 15, 16, 17, 18. And then engine was tested for no load conditions, 25 to 100% load in the steps of 25%. Fuel blends which are used was B20, B40, B60, B80, and pure biodiesel, that is P100. And also it was tested with diesel for comparison purpose. So as I told you, this was done in order to study the effect of this engine operating parameters on the performance and emission. Here, what are the engine operating parameters? That is injection timing, injection pressure, compression ratio, and load. Is it right? Load and fuel blend. See the performance you can see here for the engine. You can see with compression, as your compression ratio is varied, you can see the brake thermal efficiency. Brake thermal efficiency, you can see for diesel, it is highest. And there is a reduction in brake thermal efficiency as you increase the blade. For B20, it is almost, it is changing as diesel. But for B40, it is less. But as the compression ratio is increased, the brake thermal efficiency is increasing. But it is lowest for 100% biodiesel. And it is highest for diesel, and the B20 is very near to diesel. So there is some compromise in brake thermal efficiency when you are using the biodiesel. It is happening at all compression ratios. But as the compression ratio has increased up to 18, it has been found that brake thermal efficiency is increasing. But it is lower than that of pure diesel. But the reduction of the brake thermal efficiency you can see for the biodiesel blends is very less and compression ratio is 80. So from this graph, you can say that at a higher compression ratio, the reduction of brake thermal efficiency is there, but it is nominal. It is, reduction is less compared to that of diesel. And you can see that exhaust gas temperature. See, exhaust gas temperature is very good indicator of the combustion within the engine. So exhaust gas temperature should always be low. It should not be high. Exhaust gas temperature high means the most of the fuel which are unburned, which is not taking place in combustion, it continues to burn while the exhaust gas is leaving the engine. So that's why exhaust gas temperature increases. If there is a proper combustion taking place within the engine, the exhaust gas temperature will reduce. If the combustion continues, even in the exhaust gas temperature automatically rises. See, exhaust gas temperature you can see for diesel it is highest here, and exhaust gas temperature is reducing here as the biodiesel percentage is increasing. So this is because of biodiesel is having a lower calorific value compared to diesel. So due to reduction in calorific value, the exhaust gas temperature also reduces here proportionately. But at the compression ratio 18, you can see exhaust gas temperature variation from the diesel is very less. So from these two graphs, what we can say, compression ratio, if the engine, diesel engine is operated at a higher compression ratio, it it was the performance it was very close to that of diesel as a fuel. And brake specific energy consumption, you can see brake specific energy consumption for the diesel is maximum, diesel fuel is maximum at the lower compression ratio. As the compression ratio increases, it slightly reduces, but B40 compression ratio, B40 BSEC, brake specific energy consumption, it's found to be maximum of 16. Then as the at 17 value compression ratio, the diesel is having a highest brake specific energy consumption. But biofuel, that is B40, is having a lesser brake specific energy consumption. See, this is because of the lower calorific value of the biodiesel. As the lower calorific value of the biodiesel, because of which it brake specific energy consumption increases. In order to produce the same power, the more biofuel should be injected into the cylinder. See that B40, then P100, you can see P100 at compression ratio 17. It is less than that, it is more than that of B60 and B60. But B80 it is having the highest brake specific energy consumption. That means what? That the energy which is that is in kilojoule per kilowatt hour, it is more for that of for B80. In 18 compression ratio, you can see here that there is a small variations in brake specific energy consumption between different blends, but variations are very less. E60 is having a higher brake specific energy consumption compared to other blends. Even it is higher than that of diesel also. So next graph you can see here, carbon monoxide emission. Carbon monoxide emission is found to decrease for all the blends of biodiesel at all compression ratio. For diesel, it has been found even highest. But biodiesels, it has been found that it is reducing because biodiesel is basically rich in oxygen content compared to diesel fuel. So the carbon monoxide it reduces for biodiesel compared to that of diesel fuel. So next performance parameters we can see for hydrocarbon emissions. Hydrocarbon emission for diesel is found to be maximum at all compression ratios, and it is less for all the blends of biodiesel at all compression ratios. B100, it is having a less hydrocarbon emissions. So this graph indicates that there is a better conversion for biodiesel, just like that of diesel, but hydrocarbon emission is reduced. That means unburned fuel it is going out along with the exhaust is reduced for biodiesel blends. For B100, the hydrocarbon emission is very less compared to all other blends. As the blend is increasing, the hydrocarbon emission reduces. So as the compression ratio is increasing, the hydrocarbon emission is reduced. So next, carbon dioxide emission you can see here. So carbon dioxide emission at compression ratio 18, you can see For pure biodiesel, carbon dioxide emission is highest. So as I told you, the biodiesel is rich in oxygen content. The carbon dioxide emission is, that's why more at compression ratio 18. It is not of much concern because carbon monoxide is much concerned emission content compared to carbon dioxide. For diesel, again, carbon dioxide is less, but for biodiesel, carbon dioxide is more. For diesel, carbon monoxide emission found to be very high compared to our biodiesel blends. But for other blends, as this one, carbon dioxide is concerned, emission of carbon dioxide is less for diesel compared to other biodiesel blends. Nitrogen oxides, you can see, nitrogen oxide is more for all the biodiesel blends compared to diesel. So this is mainly because of better combustion, that increase in temperature is taking place. As you increase the compression ratio here 80 for B20 blend, the carbon dioxide emission is so nitrogen oxide emission is more NOx. And as you increase the blend percentage in carbon compression ratio 80, the NOx production is increasing. So that is the main threat of using biodiesel in diesel engines. So there are various additives which are being used by researchers, many researchers, in order to reduce the NOx emissions. And also we will see the effect of other parameters. Smoke emission, you can see smoke emission for diesel is lower. Smoke emission increases slightly for these biodiesel blends as you increase the compression ratio. Then we will see our performance parameters as you change the injection pressures. So injection pressure, three levels of injection pressures were used here: 180, 210, 240. You can see as the injection pressure is increasing, brake thermal efficiency of the engine increases due to the better atomization and better combustion taking place. The brake thermal efficiency of diesel is again highest for all the injection pressures. But as the blend percentage increases, brake thermal efficiency increases. B20, the brake thermal efficiency was least. Then B20, it is very near to diesel. But for pure Honda oil, you can see brake thermal efficiency found to reduce to large extent. So then B40, you can see B40, B20, there is no much difference here in brake thermal efficiency. And as you increase the blend, the brake thermal efficiency reduces. That's why you have to compromise for brake thermal efficiency at all injection pressures when you use biodiesel as a fuel or blended fuel. What about exhaust gas temperature? You can see that diesel is having the highest exhaust gas temperature. Diesel fuel, it is having the highest exhaust gas temperature compared to our biodiesels. At all the injection pressure, you can see it is increasing proportionately. The exhaust gas temperature is increasing proportionately. At 240 bar, exhaust gas temperature is highest. So exhaust gas temperature with respect to injection pressure, as the injection pressure is increasing, so there will be a fine atomization. If you increase to larger extent, these fine atomizations we may not take part in combustion here. So that is going out of the out along with the exhaust gas. So while traveling through the exhaust passage, we take part in combustion. That's why the exhaust gas temperature is increasing here. So, and also the increase in the injection pressure, it reduces the brake thermal efficiency much. As even the brake thermal efficiency increasing, but here it has been found that if you want to use more biodiesel percentage, the brake thermal efficiency reduces compared to that of diesel. So increase of injection pressure to higher value, it is a concern by taking into consideration brake thermal efficiency and other that exhaust gas temperature also. So brake specific energy consumption, you can see it, if you increase the injection pressure, brake specific energy consumption is reducing here. For diesel, you can see at 180 bar, the break specific consumption and compare it to 210 bar at that of 210 bar. That 210 bar it is reducing again, 240 bar it is reducing proportionately for all the biofuels. But B20 diesel again it is the trend is almost same. The difference is very less. As the biodiesel percentage is increasing, the break specific energy consumption is increasing here. This is because of lower calorific of the biodiesel. The break specific energy consumption increases as we increase the percentage of biodiesel in the blend of diesel and biodiesel. In carbon monoxide emission, carbon monoxide emission decreases as we increase the injection pressure here, because the injection pressure means there is a better fuel mixing, better combustion, so carbon monoxide emission reduces. But it reduces for as you increase the blend percentage, the carbon monoxide is continuously reducing here. At 240 injection pressure, it is very less compared to 210 and 180. So that is one of the advantage of increasing the injection pressure. So another disadvantage is exhaust gas temperature increases as the injection pressure is increasing. So next, you can see here, hydrocarbon emission reduces as we continuously increase the injection pressure. Then carbon dioxide is increasing here as the injection pressure is increased. Carbon dioxide increases is not a concern here. It may increase, that means it shows there is a better combustion here. The nitrogen oxide, it is increasing as you increase the injection pressure. So it poses a threat. Nitrogen oxide is not desirable as a emittent. So it poses a threat. So as the injection pressure is increased here, it is continuously increasing. It is the highest for this biodiesel. As the biodiesel percentage is increasing, the NOx emission is increasing continuously. For diesel, it is lowest at all the injection pressures. Smoke emission, you can see it is continuously reducing here as we increase the injection pressure, because this is because of the purpur mixing and combustion here. For B20, it is almost near to diesel. As we increase the biodiesel percentage, the smoke intensity is increasing. So now we will discuss static injection timing. So injection timing was varied from 19 to 27. So and also 23 is in between 19, 23 and 27. As the static injection timing is increased here, the brake thermal efficiency increasing, then start reducing. So at 19, that is at retarded timing, 19 static injection timing, that is 19 degree before TDC. It is in brake thermal efficiency was lowest. And as the injection timing is advanced here, it was advanced up to 23, it has been found maximum brake thermal efficiency. And on further advancing it up to 27 degree, the brake thermal efficiency started reducing here. And for all the static timings, for diesel it is found to be highest, and it started reducing as we increase the blend percentages. Then exhaust gas temperature, you can see it is reducing, then again increasing as you advance the injection time. But brake thermal efficiency and exhaust gas temperature, you can see it is lowest for here 23, but it is found to be high. Brake thermal efficiency is found to highest for 23 here. So always higher brake thermal efficiency is desired. May increase slightly here, but brake thermal efficiency slightly may reduce. So you can see brake specific energy consumption, it reduces as you advance the injection timing, and it increases when you move the injection timing from 23 to 27. So carbon monoxide, you can see it reduces, then again it increases, the injection timing is advanced. In carbon dioxide, it increases, then decreases. Carbon dioxide, carbon monoxide, always it happens in reverse. So nitrogen oxide, you can see as the injection timing you advance, it increases, and further advancing it slightly drops, but not much variation. But at 19, the nitrogen oxide is and NOx emission is very less at retarded timing. 19 we call it as retard, 27 we call it as advanced. So at 19 timing it is very less because there is no this one combustion is not much as a 19 degree before TDC. The air is at a higher temperature. Ignition delay reduces. That's why this network NOx emission will reduce. So if you inject the fuel at 27 timing, there is a more delay period. Suddenly, all of the fuel which was injected take part in combustion at a time. So the temperature increases suddenly. So there is a NOx generation. So at retarded timing, it is less here compared to advanced time. So for the biodiesel, it is increasing. As you increase the biodiesel percentage, it is increasing. So hydrocarbon emission, you can see at timing here, retarded timing, hydrocarbon emission and advanced timing. There is no much effect of the injection timing on hydrocarbon emission, but the effect is there to a certain extent. But as you increase the biodiesel percentage, the hydrocarbon emission started reducing here at all the timings. Mainly the timing effect is on nitrogen oxide that we want to reduce using the biodiesel percentage, using biodiesel plant. As you increase the biodiesel, the nitrogen oxide is increasing here. So that retarded timing you have to use whenever using biodiesel, but you have to look after the break thermal efficiency also and plate specific energy consumption also. Because if the nitrogen oxide emission reduces, if the break thermal efficiency also decreases proportionately, then it is not economical to have that retarded time. Smoke intensity, you can see here at retarded timing it is higher. Then as you advance, it started reducing here. So what are the drawbacks of this experimental investigation, and why if there is a need of some tool, software tool in order to have better optimization. So there is a huge collection data experiments and it requires a lot of time. And there is a conflicting nature between performance and emissions setting specific levels of compression to injection timing. So that we have observed from this experimental data. So we cannot come to conclusion on basis of the experimental data that there should be a proper levels of compression ratio and injection timing and pressure, that is at blend also. So these are all the injection parameters. So some genetic algorithm nowadays, so many tools are there. Gray relation analysis also has been used nowadays, and so many other tools are using computerized research and optimization procedures which are created upon the mechanism of normal hereditaries and usual assortment. You can use more than two tools, 3 tools, and you can cross check with experimental, so that you have to come that researchers should come to a conclusion. So this is the best tool for this system, AC engine system, and they all function upon string codes or variables, the genetic algorithm. And added benefits of this is that it separates the search area of the function of continuous type also. So GS use only the yielded values of the function at different distinct points. So it is able enough to handle a function which can be discrete or discontinuous. Any type of functions it can handle. And here search function may be continuous or discrete, that also the GS genetic algorithm can handle. So genetic algorithm operators are easily detect, which can easily detect the similar structure strings, enabling it to make an effective search function. So you understood what are the drawbacks of this experimental design. So genetic algorithm, before going to genetic algorithm, we should have model here. In order to go for genetic algorithm, we should have a model. So model I will show you here. Suppose here break specific energy consumption is the output performance parameter of the engine. Break thermal efficiency also is the output parameter of the engine. Exhaust gas temperatures. These 3 we can consider it as a performance parameters of the engine, main performance parameters of the engine. And these 5 CO, CO2, NOx, HC, smoke 5 are called as emittents. These may be emission characteristics of the engine. So this depends upon what? This depends upon engine operating parameters, that is compression ratio, injection timing, fuel injection pressure, load, and blend. So these are all independent parameters. So these are all right side, they are all dependent parameters. So you should have a model here. In the researchers, it is the regression model. So regression models were developed here. and their coefficient of correlations values are also given on the right hand side. So these models you have to use it in. Before using those models, you have to check that model for the mean absolute percentage error. So then you have to test that model, then you have to find out the mean absolute percentage error. If the error is less and accuracy is more, you can use that model. So when you are doing multiple object optimization also, you can the researchers have done once by considering performance alone. Next step, exhaust gas emissions are alone considered. Then they considered both performance and emission, giving equal weightage. Then weighted multi-objective optimization also was used. That means you can give different weightage to performance and emission, and also you can go for multi-objective optimization. So researchers usually they are using these types. So what happens from this, if you consider performance alone, say levels of this engine operating parameters may be slightly different, exhaust emission alone may be different. So from this you will understand how much compromise you have to make for the performance in order to reduce that NOx emission. So you have to choose the level of these operating parameters considering both performance and emissions. Because if you have good performance, emission is worst, and it is not good. So because nowadays more stringent and stringent emission norms are applicable to all the engine manufacturers, it may be a stationary or mobile vehicle. So weighted multiple optimization, you can see you can give different weights, 50% weight, 190. Similarly, you can change the weightage for emission, and you can find out what are the levels of the compression ratio, SAT, blend. So it is by changing the weights. So these levels you can find out. From this level, considering 50-50 weightage, these are the levels you got. So what is the 50-50 means? Performance also important for 50%, emission also important for 50%. So these levels you get. So these levels are what? These are approximately 17.6 here, 22.8, 222 injection pressure. Then researchers got it as 58%. See, by changing this operating parameters, the blend found to be for 58%. And by 58%, how much that compromise was done? Compromise was done on brake thermal efficiency around 1%. So you can calculate the 1% will change the brake thermal efficiency, and you are increasing the blend up to 58%. It is well aimed. See, in artificial neural network modeling was also used for predicting the performance and emission parameters. The engine operating parameters were 5: compression ratio, injection timing, then injection pressure, load, and blend. And these are the outputs. So there are different artificial neural network functions that you have to do training here by using existing values. Then you can find out the output also. The architecture by ANN, you can use different architecture. You can have more than one hidden layer or single hidden layer. Then by trial and error method, you have to fix the number of neurons in hidden layer. And then you can use different transfer functions. These are the algorithms. These are called as transfer functions you can use. Then you can go for feed forward propagation algorithm. So transfer function here in this Leeuwenhoek-Marquardt train LM algorithm going to be best for this engine system applications. See the prediction accuracy for different transfer functions you can see here using the genetic algorithm, feed forward. This one feed forward algorithm. So train LM going to be better in both training and testing. So the B60, B58 approximately it was considered to be B60 for diesel and pure oil. ANN prediction result, and experimental result. Both ANN experimental and error was found. Error was found to be very less here using this compared to this predicted value and actual value, and experimental value. So all the output values are found here. See experimental and simulated output of the ANN. The engine, that is performance parameter and the emission parameters, which is based upon the setting up the operating parameters which were got by genetic algorithm that was tested using ANA. Predicted value and experiment. Experimentally again, it was already the results were there about P60, diesel and pure nile. So that ANA predicted result and experimental results were taken, and their error is found out. So error was found to be very less here. Only for carbon monoxide error was -600. The remaining all error is less here. So based upon this study, what we can come to conclude here. So there is a high demand of diesel fuel, which is necessitated the need of renewable biodiesel for cheap sources. And extensive use of biodiesel give rise to improvement in engine performance and emissions. So what happens only for the research purpose, testing is done on the engine, and engine is kept idle for many days. So what happens? There will be a gum formation, and the pistons will be sticky. So this can be avoided by using the biodiesel continuously in the engine, not only for the purpose of doing research, but also many research also is going on for the lifetime analysis of the engine parts, and also lifetime analysis of the biodiesel use in blended form and also in pure form. And reduction of emissions shows biodiesel use in transportation sector globally. Definitely, the greenhouse gases will reduce to large extent by using this. By only using 5% biodiesel in all transportation vehicle, it has been projected to reduce carbon greenhouse gas emission by 30%. In highly polluted area, highly polluted or highly traffic area, if the biodiesel is used, the 20% reduction of the greenhouse gases can be expected. So, and policies establishment all around the globe for adoption of biodiesel fully or in blends, it promotes marketability and use. So policies should be established throughout the globe to promote its use and marketability also, because regionally they have to make policy for regionally available biodiesel sources, stocks. And the main advantage of making the biodiesel use is it creates a job market. So local labor force can be used, and it increases the existing industry, also oil producing industries, it can be expanded, and it can be exported also. So viable foreign exchange earnings can be the benefit, and it can be done by importing and exporting of biodiesel fuel. So as I told, greenhouse emissions are reduced and more can be increased in biodiesel production and combustion as a fuel. And with advantages of biodiesel, renewability is a main advantage and better engine performance. So manufacturers can make good transaction in automobile market by using biodiesel as a fuel, because more and more stringent emissions are coming. So using only the diesel as a fuel, it is very difficult to meet the stringent norms which are coming out in the government policies. So more end users can acquire these engines with reliability and satisfaction of using biodiesel as a running fuel. So over a time, switching to diesel engines can be expected to revolutionize the future use of liquid fuel and power engines in automobile vehicles. See, in all developed countries, few years ago, there were no use of diesel engines in passenger cars. It was only used in heavy trucks and buses. But nowadays, they are also switching over from petrol cars to diesel cars. Thank you.
Participant, any questions to ask? On to any queries?
Very good morning, sir.
Good morning.
Sir, regarding experimentation, sir, you are used single cylinder diesel engine, I think.
Yes, yes, yes.
If we use 4-cylinder diesel engine, can we get the better results, or which one is efficient, sir? Single cylinder or 4-cylinder?
See, actually, that whatever the effect which you are observing in single cylinder, same effect will be observed in 4-cylinder also. So single cylinder data, whatever you are getting, it is a preliminary data. If the 4-cylinder engine is available, it is well and good. Because in 4-cylinder, what happens, whatever the products of combustion, it will get balanced when it goes through the exhaust. So performance also will be better in 4-cylinder engine, and also emission also will reduce compared to the single cylinder. 4-cylinder, you will get averaged output of the performance as well as the exhaust emission. So if you do it on 4-cylinder or multi-cylinder, it is well and good.
Thank you, sir.
Hello, sir.
Yes, madam.
Is catalytic converter required in a diesel engine?
Diesel engine, see, nowadays in vehicles, actually these engines, whatever the experimental testing which is being done by the researchers, it is a normal diesel engines. Nowadays, whatever diesel engines which are used in automobile vehicles, it is having a turbochargers. So because of turbochargers, there is a better combustion and emission automatically reduces. But no companies, they are ready to use this biodiesel in the more than 20% percentage in blend, and they want to test it in the engine. If they test it more than 20%, definitely the emission will reduce in turbocharged engine. So there is no, as of this one biodiesel, emission is already less, only NOx percentage is more there. So catalytic converter, there is no recommendation for using catalytic converter when you are using biodiesel as a fuel.
Okay. Thank you, sir.
Good morning, sir.
Good morning.
This is Preetha, sir, from Hyderabad. I'm from
Yeah.
Department of Microbiology.
Yes, very nice.
Sir, I think my question may be a little bit absurd, but recently the Ford company announced that the future is with the electric cars. So now, in your conclusion part, sir, as you said that over the time switching on to diesel engines, it may be the future. So, sir, can you just explain me how you can relate these two statements, and in terms of a sustainable concept, how come this particular diesel engine may become a sustainable approach, means in the future?
Very good question. See,
Thank you.
See, electric vehicles are now coming into market. You see the cost of the electric vehicle, initial cost is very high. It cannot be afforded by a common man. So these diesel engines have been invented over the years by putting so much of cost on the research and all. So nowadays you can see there is a turbocharged diesel engine which are used in the cars, which were previously diesel engines were giving only mileage of 8 km, 10 km per liter. Now it is giving 20 to 25 kilometers per liter. So what is happening due to this stringent emission norms, the companies, they are not able to cope up with the existing engine. Their cost of reducing the emission is increasing by using only diesel as a fuel. So they adopt, so many companies, they have stopped also manufacturing the diesel engines. See, Maruti, they were manufacturing a Swift Desire vehicle. It was very economical. They stopped manufacturing because of Euro 6 norms. So if they want to achieve that Euro 6 norms, compulsorily they have to go for using 10% or 20% diesel blended with biodiesel with diesel. So if they blend it, automatically they meet the Euro 6 norms and they start manufacturing. Then if the same vehicle, if you want to purchase electric vehicle, the cost will be more than double. Yeah, and electric vehicles, it is having its own drawbacks. It cannot run for a long run. The electric vehicles, suppose if you make it fully charged, it can go for 300, 250. It is having its own limits. And also electric vehicles are not too proven. It will not give consistent mileage with respect to your charging of battery. If the elevations of the road is changing, if you are going uphill, too much uphills are there, battery will exhaust very early. So that's why, so diesel engines using the blend of diesel, biodiesel, it is very much advantageous and economical and gives geographically, it will give by using the different resources, it will open up the job market also.
Oh, thank you, sir. Thank you, sir. Sir, another question, sir.
Yeah, yeah.
Sir, in case of this hybrid, this engines nowadays, which
Yeah.
are, yeah. So there, I think, as you said, the blended biodiesel, right? The fuel, which is, so if at all it is blended, so that is a more advantageous, sir.
Yes, yes, sure, sure. If when say railways, by using only 5% biodiesel blending, they have reduced almost 30,000 crore per year input. So if when it may be hybrid or it may be a pure diesel vehicle, blending always is advantageous.
Advantages. Okay. It means that will also increase the engine, that is the running life, the running this thing, sir.
Yeah, running life, what is happening? The people are thinking that biodiesel, it will be sticky gum formation because of its higher viscosity and all. So, and also people have been, researchers have been found 20% biodiesel blending, it will not make any harm to the engine in the long run also.
Okay. Thank you, sir. Thank you so much, sir.
Welcome, welcome. Thank you for asking good questions.
Okay.
Any other questions, participants? Sir, one question on chat box. Let's see that.
Yes, sir.
One question is asking in the chat box.
Yes, yes, sir. How to decide amount of alkali to be added to feedstock to accelerate fermentation rate in biodiesel. See that it actually biodiesel production, it is a different thing, and increasing the yield, it is also a different thing. That how much of alkali to be added, that is the optimum level of the alkali to be added to feedstock to accelerate fermentation. That is you have to experimentally, you have to try it. Then you have to decide. It is more of chemical in nature.
Chat box.
When you are using 100% biodiesel, see the properties of biodiesel is very much similar to diesel. So there was no need of changing any modifications. Modifications was done only in the engine operating parameters. But what is to be done whenever you use 100% diesel, you cannot keep the engine idle for more time. Immediately after using 100% diesel, you have to run it using diesel. Otherwise, what happens? There will be gum formation within the engine, so it will harm your piston, cylinder, piston rings. So that is the main thing you have to keep it in mind whenever you are using 100% biodiesel.
Question, participant? Question, participant? Okay, I think no questions, sir. Thank you very much. Just one more question is coming on because of your interesting topic is taken in detail. Our participants ask questions.
Thank you. Thank you.
One more question coming on the chat box, sir.
See, what is the difference between diesel and biodiesel chemically? So what happens here? If you take the oil, it may be edible oil, non-edible oil. It is having a lot of difference in terms of its properties compared to diesel. So when you biodiesel, you have to convert diesel, the oil you have to convert it to biodiesel using transesterification, and so many other type of process are there. So by that, what happens? The properties of biodiesel will be very much similar to diesel. So chemically, there is percent more oxygen in case of biodiesel compared to diesel. So you can see that equations. You can see after transesterification how this oil converts into biodiesel. You will come to know the chemical structure, aromatics chain. Okay, many types of biodiesels are there nowadays. You can go for even that calophyllum, inophilum, with some additives, nanoparticles, silver oxide nanoparticle, nickel oxide nanoparticle. It has been proved to reduce the NOx to very greater extent. With some additives, you can try. And Simoroba oil is also there. It is also non-edible oil. Algae oil, if you get algae oil, it is a very well and good. You call it as a third generation biodiesel. But using this existing non-edible biodiesel, you can go for many researchers still there is a option, door is open for doing the research. You can use some additives, and you have to see, you will see that the percentage of biodiesel blend which can be blended automatically, it increases if you blend with some nanoparticles.
I think no question, participants. Thank you very much, sir.
Thank you, sir. And thank all participants
One more question.
for the patient learning, patient listening.
One more question on chat box, because it is informative or even in detail. Participants are starting asking the question.
Yeah. See, blending is suppose your 5 liters biodiesel are there. 5 liter diesel. 5 liter diesel. You have to calculate 20% how much will be the biodiesel. Then you have to stir and mix it, and you have to pour it into your tank of the engine. By volume, mainly because by volume. See, experimentation, you can do it in anywhere where there is availability of the engine and test setup. Mainly the emission analyzer, gas analyzer and analyzer should be there. So definitely you can use that. You can approach many institutions or many R&D institutions or diesel engine manufacturing units. You can see from Greaves Cotton Limited is there, and some other companies may be there. Some institution you can go, only you can see that. You should see that the analyzer and smoke meter should be calibrated, and all the other devices it should be calibrated. You should do error analysis before going for the experimentation. See, biodiesels are available. Biodiesel manufacturers are so many are there. So here near in Maharashtra, near Baramati, Biodiesel Corporation is there. They are also manufacturing biodiesel. And in UP also one place is there. They are also manufacturing. In Karnataka, near Shivamogga, there is one manufacturer of biodiesel, especially calophyllum and Karanja Jagrom. Also, they are manufacturing. You can get biodiesel for many places.
Thank you, sir. Thank you very much.
Thank you, sir.
Very systematic and good information for this session, and given by details on use of biofuels in the IC engines in detail. All the participants, that's why actively participated and asking the question continuously, because of your explanation is very good. That's why once again, thank you on the behalf of our department and college. A wonderful talk on the use of biofuels in the IC. Thank you, sir.
Thank you very much, sir. Thank you to you and your team for arranging this ATAL FDP and inviting me. Special thanks to you and your team. And also I thank all participants for their patience listening.
Thank you, sir. Thank you.
Thank you. Thank you.
Participants, break taken 30 minutes. Sharp 12 o'clock, so started with the session 5 on second day. Thank you.